So welcome all of you. So in this video, you will get an idea about how to use the static analysis in Feast software. Feast is finite element analysis of structures. This is actually a software developed by Indian Space Research Organization, Vikram Sarabhai Space Center, and this is supported by the pre or post processor Prewin. So this is a wonderful software. We can conduct static analysis, vibration analysis, buckling analysis, frequency response analysis, random response analysis, transient response analysis, heat transfer transient analysis, etc. So simple example of static analysis, a cantilever beam, static analysis of a cantilever beam. So our objective is to find the deflection, stress, strain, shear force and bending moment diagram. You have to find the deflection, the stress, the shear force, strain, bending moment diagram of the cantilever beam. And the analysis type is static analysis, and the modulus of elasticity is 200 gigapascal, and Poisson's ratio is 0.3 and point load is minus 3 Newton at one end. So first you have to create 2 points at 0, 0, 0 and 500, 0, 0. So I will open the, here I will open the geometry key point and create. So here you can see geometry, create key point. And you have to select by X, Y, Z option. Key point create by X, Y, Z option. Geometry, key point, create, and this option by X, Y, Z option. Then here you can see you have to enter the coordinate data. So the coordinate data is actually 0, 0, 0. So I will click apply here, and then I will enter the second coordinate as 500, 0, 0. Second coordinate as 500, 0, 0. Click apply. So here you can see 2 points. Then the next step is you have to create a line between these 2 points. So you have to select the geometry, curve, and create line. So again select geometry, curve, create line. Then you have to select this point and select this point. Select this point and select this point. Then after that you have to, so here you can see okay. So then the next is next step is you have to meshing using beam elements. So mesh, FE mesh, bar, mesh, FE mesh, and select this bar, and then curve 1, then element size 0.3, and type is 2 noded. Is it a 2 node or 3 node? It's a 2 node. then subdivisions 25, then bias 1.0. Click apply. Okay, so then next is the displacement boundary conditions. So next is load boundary conditions, structural displacement, add. Then node IDs. So here nodes. Okay. So node. Then the busy value. Click here. Translation and rotation. Here 102 0 3 0 405 060. Okay. Then enter. Okay, so boundary conditions complete. Okay, then the next step is you have to specify the material properties. So property material isotropic. So property material structural isotropic. So element ID is 1. Sorry, element ID is old. Then material data, modulus of elasticity 200 gigapascal. Then Poisson's ratio is 0.3, 0.3. Then okay. Okay. So that's all about the then the next step is specify the beam properties. Specify the beam properties. Physical beam properties standard section. So then cross section type rectangle. So the cross section type is rectangle cross section and the breadth and height. So 35. Breadth is 30. This is 5. Then click OK. Then next is specify the point load boundary condition, point load. So here you have to select the load boundary condition, then here point load. Okay, so node IDs So node number 26 and data is component fy, component is fy, then apply. So here you can see here you can see load. Then next is you have to select the analysis type. So select analysis type. Here analysis type. You have to select which type of analysis. So this is static analysis. Select this static. Then you have to set the analysis option. A linear solver as multi-frontal. So analysis options. So linear solver, multi-frontal or conjugate gradient, multi-frontal, then apply. Then next step is you have to save this file. Okay, then you have to submit the job into Faced. Run the solver. Analysis, run solver. Go to analysis, then run solver. Yes. So here you can see finished successfully. And then you have to perform the post processing. First one is deformed shape. So post deformed shape. Click here, deformed shape. So when you click here, highlight maximum. So the maximum displacement is 2.00016. Here I will select superimpose, then animate deflection. So you can see the animation. Then next is stress contour. So select post beam plots and stress contour. Post. Then here you can see beam plots and stress contour. So select axial. So bending XY. So I will select this bending XY and click apply. Decimal places 2 and number of contours 9 and element list 4. So minimum and maximum, minus 12 minimum, maximum 12. Then next is the strain contour. Again go to post beam plots strain contour and bending XY, then apply. Then shear force diagram. If you want to see the shear force diagram, post beam plots force diagram, post beam plots and force diagram, and component shear 1, component shear 1 and plane 1. So decimal places 2 and scale factor is say 1, number of contours is 9. Click apply. So here beam force shear, you can see minimum -3, maximum -3. Then bending moment diagram component, you have to select this as BM1 or BM2. So here I will select this BM2. Then I will click apply. So that's all about this. Thank you.